Today we're going to be learning about exponential regression. Here is a list of calculator steps for your reference, so if you need to go back and take a look at these steps later, they're there for you guys. Okay, our first example, we have year versus crocodile population at a zoo. So what we're going to do is we're going to enter this data into our graphing calculators. So we hit Stat and Edit, and we go ahead and enter the X values in list 1 and the population, the Y values, in list 2. Next, we go back to Stat and over to Calc. Just some reminders, number 4, the linear regression, we did that back in our linear unit, and the quadratic regression we covered in the quadratic unit. So if we go down just a little bit further, guys, we will see one that says exponential regression. So that's the one that we're going to pick here today. We have list 1 as our X values, list 2 as our Y value. And if you want to store the regression equation in your Y equals screen, you go to vars, over to Y vars, enter on function, and enter on Y1. You don't have to do that, but it is nice to be able to graph the function on top of the points. And let's go ahead and calculate. Okay, so the calculator is going to give us the A value and the B value. All we have to do is plug that into this form, y equals A times B to the X. In the prompt, it did ask us to round to the thousandths place, so we would round to 3 decimal places. So if we plug those values into the formula, we get an answer of y equals 2.406 times 1.069 to the x power. Here are some questions that we might be asked as far as that exponential function. So the first one is, what is the growth rate? So if we look, guys, this b value we've talked about lessons. This b value is a growth because it's over 1, and how much over 1 tells us the rate at which it's growing. So if we look at that, it would be 0.069 as a decimal or as a percent. 6.9% is the growth rate. The second question, if the pattern continues, predict the number of crocodiles at the zoo at year 50. So what we're going to do is we're going to take our equation, y equals 2.406 times 1.069, and we're going to raise that to the 50th power. So we're putting 50 in for x. If we calculate that, we have 1.069 to the 50th power. Remember, we should do exponents first according to order of operations. And then I'm going to multiply that by the 2.406. So we get 67.6. Now, if I think about that, that's the number of crocodiles. So I can't really have 0.6 of a crocodile. So I'm going to round that up to 68 crocodiles. Okay, and taking a look, the next slide does have those answers on there. Again, if you need to look back, you'll have that math. Okay, the next example, we're asked to find the regression equation for years since 2000 versus the population of the DC Zoo. So guys, this year since 2000 is currently blank. So we have to convert these years in the left column to the number of years since 2000. All we're going to do is take the year, subtract off 2000, and that's going to give us that X value. Pause the video and go ahead and find those years since 2000. Okay, hopefully you've had enough time to find those. If we calculate those, 2000 minus 2000 is 0. 2005 minus 2000 is 5. 2010 minus 2000 is 10. 2015 minus 2000 is 15. And 2020 minus 2000 is 20. So we have the x values of 0, 5, 10, 15, and 20 versus the bird population. Okay, pause it again and find the exponential regression equation on your calculator. Okay, so if we plug in the values, again, those years since 2000 go in list 1, and the bird population in list 2. We go to Stat, over to Calc. Exponential regression is 0. I'm going to store my regression equation and calculate. Okay, and we get y equals 20.879 times 1.044 raised to the x, or for this example, we were asked to use f of t for y and t for the number of years. Some questions that could be asked: what is the growth rate? What is the population size in the year 2025? And estimate the year in which the population of birds will be 80. Pause the video, try to answer those 3 questions. Okay, for number 1, we have 4.4%. Number 2, we plugged in the value of 25. The year 2025 is 25 years since 2000. That 25 goes in for t, so f of t is equal to 20.879 times 1.044 to the 25th power. If we do that math, we get approximately 61 birds. Number 3, I'm going to go ahead and show on the graphing calculator. So in my y equals, I've already stored the regression equation in y1. So I'm going to go down to y2, and I'm going to enter in the value of 80. I'm going to have to change the window because the window that I'm seeing here is a little bit different than the one that I have stored. So I don't really care about any negative values. I'm going to go from 0 to maybe 40. And then for the y values, this is talking about the amount of birds. So I'm going to go from 0. We want 80. I'm just going to go ahead and put 100 in there so I get a good view. So there's my regression equation, guys. And there's the value in red where y equals 80. So I want to find this intersection point right here. So I'm going to go to second trace. Intersect is number 5. And then I'm going to get close to my point of intersection. And then I'm going to hit enter 3 times so that at the bottom it's telling me the intersection is at 31 and a y value of 80. So 31 years since 2000 is the year 2031. Okay, you may be asked to find a residual. A residual is the difference between the actual y value and the predicted y value. So in shorthand, residual is equal to actual minus predicted. We're always talking about y values. So if we look at a couple of examples with the bird population example that we just looked at, if I want to find the residual for the year 2020, the x value is 20, the actual y value from the chart is 52. But if I plug 20 into my equation, the predicted y value, in other words, the equation's y value, we get y equals 49. So we see that there's a difference there. The actual birds was 52. The predicted number of birds is only 49. So the residual is the difference. I take the actual minus the predicted, so 52 minus 49, and that gives me a residual of 3. Another example, in the year 2015, our x value was 15. Our actual y value was 39. If I find the predicted y value, again, I'm going to plug in that x value into the equation. So 20.879 times 1.44 raised to the 15th power. That gives me a predicted number of birds of 40. So the actual number of birds was 39, but the equation's predicting that we would have 40 birds. Again, that difference is the residual. 39 minus 40, it gives me a residual of -1. Pause the video and see if you can find the residual for the year 2000 and the year 2005. Okay, guys, here we see the answers to those last two. The year 2000 has an x value of 0. Y value, actual y value, is 22. When we plug in 0 into the equation, anything raised to the 0 power is just 1. So we actually have our initial value of 20.879, approximately 21 birds. We subtract actual minus predicted and get a residual of 1. Doing that same process for the year 2005, our x value is 5. Our y value is 25. Our actual y value is 25. If we plug 5 in for x, we get a predicted bird population of 26. So again, I'm going to subtract those. Actual, predicted. 25 minus 26 gives me a residual of -1. Okay, this concludes notes for today, guys.